Homework 2.5, question 1. Question 1 says, solve each differential equation using substitution. So this homework says use substitution. So we're going to use substitution other than checking for separable, for exact, for linear differential equation. So the very first question says, hey, you have x minus y dx plus x dy. This is equal to 0. And the question says, hey, your differential equation is also homogeneous. So it satisfies the criteria to apply substitution method. So since it is a homogeneous ODE in differential form, we use y equals to v times x as the substitution, and dy is v dx plus x dv. Pure practice. So now we're just going to use algebra to simplify the differential equation that we have. Wherever we see y, we're going to use vx. Wherever we see dy, we're going to use v dx plus x dv. So we have x minus y dx plus x dv, which is now v dx plus x dv equal to 0. Using algebra, doing the substitution, now just simplifying the whole thing. We get x dx minus vx dx plus x v dx plus x squared dv equal to 0. Okay. As you can see, these two terms, they're opposite of each other. We can cancel those out and we get x dx plus x squared dv equal to 0, or x dx equals to negative x squared dv, or x divided by x squared dx is negative dv. As you can see, it's separable differential equation. We can apply calculus by taking the integral of both sides. We have the integral of dx over x equals to negative integral of dv. We have ln of absolute value of x equals to negative v plus constant of integration. Again, remember that your v needs to be substituted back because v is equal to y over x. So what do we have? We have ln of absolute value of x equals to negative y over x plus c sum 1. Using the definition of ln, your x becomes plus minus e to power negative y over x e to c sub 1. So your x becomes c e to power negative x over negative y over x. This is the general solution for the differential equation using substitution method. Let's take a look at question 5. For question 5, we have y squared plus xy dx minus x squared dy equal to 0. It's the same process. Let us use y equals to v times x, and as you can see, dy becomes v dx plus x dv. Let us apply the substitution, just pure algebra. We get vx squared plus x vx dx minus x squared v dx plus x dv equal to 0. So we have v squared x squared dx plus vx squared dx minus x squared v dx minus x cubed dv equal to 0. So let's get rid of the opposite terms. And what's left? You have v squared x squared dx equals to x cubed dv. So it becomes x squared dx over x cubed equals to dv divided by v squared. So it is separable. Now we can apply the integrals. Calculus. The integral of dx over x becomes integral of dv over v squared. So ln of absolute value of x becomes negative 1 over v plus constant of integration. But what is v? V is equal to y over x. So ln of absolute value of x becomes negative x over y plus c sub 1. So absolute value of x becomes e to power negative x over y, e to power c sub 1, or x becomes plus minus e to c sub 1, e to negative x over y, or x is, well, c e to power negative x over y. We found the general solution for this differential equation.